So today we have some various things to do. Okay. Yesterday I was asking you guys to complete that cotangent. So how did you guys do? What have you discovered? What have you discovered about, something similar, right, to tangent, but there are certainly differences. And what have you discovered about the x-intercepts? Could I get some feedback? Could we get some feedback? Anybody? No? We didn't have time to do it? All right. So if you haven't done it, I'm going to touch these points. Okay, but I'm not going to, we're going to be, I will try to be a little faster, okay, because we don't have a whole lot of time to dwell on these, and you need to work on these yourselves, okay? So just give you some guideline, right? So it's at our fingertips to get these graphs of tangent and cotangent, right? So the process we went through is basically help you to understand how to read the graph, which is very, very important, right? So yesterday we did it for tangent, and we have a bunch of analysis. And today we're doing for cotangent. Cotangent basically is according to definition, right? So we're back to ARD. Then we know that, oh, we're gonna have some vertical asymptotes as well over here, right? We're gonna have lots of vertical asymptotes, but what are they? What are the x-intercepts? Obviously, we don't have the y-intercept, right? Because the domain is k pi. When k is 0, the input angle cannot be 0 times pi. 0 times pi is 0. Therefore, there's no y-intercept, right? So there's no y-intercept. But we have x-intercepts, right? What happens at x-intercepts, right? So what are these points? If you read the chart, right, you may have to use zoom, but you know that the graph can only show you finite number of those. And how do you get the general form, right? That's typically what's wanted by your professors if in similar situation. So you have to be able to figure out just from ARD, right? So first, let's do the easy part first, right? For the x-intercepts. What does x-intercept means? The input is given. Oh, no, I'm sorry. The input is unknown. The output is given, right? The output is 0. So your x-intercept will look like what kind of points? The kind of points you're looking for is that you don't know the input, but you know the output is 0. That's how they look like. Okay. So I need to set this a little bit larger, 175%, so you guys can see. So this is what I want you guys to see, okay? You see that for tangent, if you guys are trying to catch up the notes, and there's a negative sign, on the shoulder, which means approaching pi over 2 from smaller than pi over 2, okay? So we have introduced all these symbols, even though I will not be testing you guys on that, but these are the things you're going to see in calculus classes. Okay, I will not be testing you guys on that. So these are just my perks to you. You get it, you might get a few more points or 10 more points on your next class. If you don't, if you just don't want to deal with it, and then you will have opportunity to deal with them in your calculus classes. But anyway, without further ado, so your points we call x-intercept is going to be something like this. Right? The input is unknown, the output is given. What's the input? The input, obviously, is the angle from the domain, right? So what will be the output? The output obviously is going to be the cotangent ratio, right? And we know from definition, the cotangent ratio is x over y. What is x, right? So we have that stage. Remember, we have that stage out there, right? And on that stage, we have simplified. We know that, the red is x, the blue is y, right? Today, later, we're going to talk about where, how is this, unit circle, where it came from, right? We're going to talk about that later. But right now, we just want to be continuously connect to what we did last time, okay? So now we came to this point, and then because it's x over y, therefore it's going to be the red number divided by the blue number. If we do the red number divided by the blue number, what happens? When we'll get a zero ratio. The red number divided by the blue number. You guys see that analysis? The analysis. This is what we call analytical skill, critical thinking, right? You connect the dots, And we have done this multiple times, right? We've done this for sine, which is a blue number, cosine is a red number, tangent is the blue over red, and cotangent is red over blue. So they're all very similar. And these are considered pretty basic mathematics. So you look at the red number divided by the blue number, right? Starting from here, right? From the standard position. 1 divided by 0, undefined. That's why, any angle terminates on this horizontal line. It's not going to be, it's forbidden. It's forbidden because you have an input, you don't have an output. The output does not exist. So red number divided by blue, red number divided by blue, red number divided by blue. You can do all of that. And here we go. We have a 0 divided by blue, 1. 0 divided by 1. When we do 0 divided by 1, what do we get? We get 0. 0 divided by 1 is 0, right? You learned that back in pre-algebra. Any question about that? I know some of you might be confused and say 1 divided by 0, 0 divided by 1. What's the difference? Nobody has a question about that, do you? Anyone has a question about that? Well, this is 5 courses in 1. If you have a question in any area, just let me know. I will help you. So no question. So 0 divided by 1, that's going to be 0. So that ratio is 0. Okay, so that ratio is 0. Okay, so the angle from the domain of cotangent and give it to cotangent, right? That rule, it produces ratio, right? And that ratio is the red number over the blue number, x over y, right? And we want that to be 0. When will it be 0? When the numerator is 0. Denominator is not 0. So when red is 0, the blue is not 0, right? We cannot divide by 0, right? We cannot divide by 0. Do you guys see that? So we have a situation here that 0 divided by 1. Yay, we found it. That will guarantee a output equal to 0. Okay, an output equal to 0. That's what we want. So we found one terminal. And I'm going to use the terminal. I'm going to use the red, right? We had a discussion about this yesterday, right? Red is a forbidden. I'm sorry, not red. My bad. This is blue. I'm sorry, this is green. Sorry, this should be green. Why should it be green? Because it's okay, right? We're looking for x-intercept. And this other one is red. Okay, this other one is red. That's forbidden, right? the green needs to identify what is identify? Identify the zero ratio, cotangent ratio, which is the output, right? So any angle terminates on the green is what? On the green, which is on this terminal, it's going to give us 0, which is the output equal to 0, right? Those angles will be the input, and we're looking for those input. So this is really from D to A, ARD, D to A. And keep going, right? So we keep going, and we continue to measure our points, measure our angles, and we get this. We do red and red over blue, red over blue, red over blue, red over blue. Oh no, -1 divided by 0. What happens? That's forbidden, right? That's forbidden. So we're gonna have to put a red over here, which we already did, right? So we need to put a red over here because we get a dividing by 0 case. That's undefined. This is the line that's forbidden for cotangent as terminals of angles. So we cannot be there. We cannot be there. But we have already done that, right? So continue. We continue. Continue. Oops. Should be green, right? I wish the program just read my mind, right? Oh, so we continue to do that. You pass all these points, red divided by blue. There's a lot of red and blue in between, you understand, right? They're not special angle, but they will not be dividing by 0. So we keep going. We do the red divided by blue, red divided by blue, boom, we got here. And the red is 0. The red is 0. The blue is -1. 0 by -1 is going to be what? 0. So we found the two terminals. We found the two terminals. So what are the features of these two terminals? What are the features of these two terminals? They end at pi/2 or 3 pi/2, right? So you can measure any way you wish. So where are we back to? This looks a little familiar to us. This should look very familiar to us, right? When did we deal with similar angles, right? From D to A. What are all the angles that terminates on the blue, on the green, sorry. What are all the angles that terminates on the green? What are they? When did we do it last? When we discussed the domain for what? For what? You guys should make these connections, right? You guys should make these connections. Otherwise, what do you learn? You have to remember everything. Remembering everything is impossible. It's confusing, it's frustrating, and you're not going to do it very well. It's making these connections make you do well, okay? So how do you express all these angles that terminates on the green? Anybody would respond to me about that description? You have a pi/2, right? You have a -pi/2, right? Right? You can have 3 pi/2, right? And you can have a -3 pi/2, right? This process can keep going, right? You can have what? -5 pi/2, right? So all these angles you can measure. So what do we get? Can someone describe all these angles that terminates on the green using ARDA? ARDA. So you tell me that A is super duper important, right? ARD, ARD, ARD. So what are those angles that will cause this to happen? To cause the output equals 0. Those are the angles we're looking for, right? Because those will be our x-intercepts. Do you follow me? So what are they? That should be odd number multiples of what? pi over 2. Do you agree? Those quantities. That's right. Thank you, Farouz. Right? Odd number multiples of pi over 2. How do we express it algebraically? 2k plus 1 multiply pi over 2. That's what your professor wants to see. Your calculus professor wants to see that. If he sees that, or she sees that, she will give you a point. If he doesn't, you don't get the point. And this includes all the math professors you're going to see in four-year schools. Okay. All right. So with that, we get our input 2k plus 1 pi over 2. The output is 0. There we go. So we're going to put that in our graph. Where, okay, here, right? Over here. Whoops. Paste. Copy and paste. That's how you get it. That's how you get it. It's all from ARD. It's all from ARD. Now, how do we analyze these? How we analyze these? If you start from the graph, right? If you start from the graph, you need to realize that what you do is that your curves are divided by multiples of pi, right? Because if you look at pi, you look at the forbidden, right? What's forbidden? A cannot be multiples of pi. So A cannot be 0, cannot be pi, cannot be negative pi, cannot be 2 pi, cannot be, 3 pi, negative, so positive, negative on both sides. So in between 0 and pi, you have a nice smooth curve. And between pi and 2 pi, you have another nice smooth curve. So you're going to see that, right? But when you see that graph on your picture, okay, so I'm gonna bring this picture over here on the top and make it larger, right? So you guys are pretty good at using calculators, but when you do that, okay, I'm not against technology at all, but you just have to understand that graph, right? A lot of our students don't understand that graph. Right? They don't understand that graph. You ask them what's the curve, they say, oh, they get it right away, no problem. But if you ask them to mark a couple points and they have no idea. If you ask them what is the x-intercept, what is the y-intercept, they don't know. Then you don't know the graph. Then you really don't know the graph, right? All right, so from the graph, we can see the domain is also told, right? So you need to see that connecting with the domain, right? This point is forbidden. That point is forbidden, but that point is hard to recognize. But there's a point right here. It's not on the dot. It's not on the dot of 3. It's not on the dot. It's approximate. In fact, this is pi. So this will be 2 pi, 3 pi. On the other direction, that's negative pi, negative 2 pi. Okay, so these crossings, which are the forbidden input for cotangent, are the k pi. Are you guys with me? As the k runs from 0, positive 1, negative 1, positive 2, negative 2, that's what it means. That's what it means. You guys follow me? And then the question is, if we look at the, you can still plot some points, right? So if we don't plot the points, let's just observe from the graph. What can we get that? How we can get those, What
the fuck? Wait, why did we kill her? Because she's the one that snitched. Oh.
Nicole, are you making some comment? We cannot hear you very well. No? Okay. But anyway, so your pieces of curve is between these, the vertical lines, okay? The vertical line that parallel to y-axis. And we know this one, this is x equals 0, right? This is x equal to 0.
Dude, that's even worse. kill both of them. They said that Zhang should.
Okay. All right. So that's what it is. So we have all these forbidden. So I'm going to draw those. And what we just found? What did we find? The x-intercept, what are those? Right here. These are the multiples, the odd number multiples of pi over 2. Do you guys follow me? You see? But you have to be able to identify those points, because it's hard to identify those points from the graph, right? Even if you can zoom and they give you the pointer to that point, what you get is a decimal number. And you, professor, don't want to see those decimal numbers. They want to see that precise number. Remember, you see a lot of the questions I have phrased in such a way that you have to give me the precise number. Then you say, well, can I use 0.33 to replace 1/3? No. 1/3 is 0.333 followed by infinite number of digits. If you use 0.33 to replace 1/3, that answer, you're gonna get 0. Depends on how the test is designed. Okay. So you need to learn how to represent precisely. Why? Even in your future field, if you know how to express your quantities precisely, that will guarantee you have a better result in the end. Right? So you're going to do the rounding, the last step. So the rounding, you can keep as many digits as possible. So this is about numerical analysis. How do you ensure your precision, the result of your precision? But anyway, so what you see here is that in order to identify these forbidden points or the x, you still have to be able to do the analysis. You still have to be doing the analysis. So now we're back to our task, right? What happens when we getting closer and closer to 0? Right? What happens when we get closer and closer to 0? Well, when we get closer and closer to 0, the output is gonna get as high as possible. Right? We have done similar things for many situations. How do we express that mathematically? Okay, I'm going to show you in a second. And in the other direction, we're going to approach pi. So we're going to approach this forbidden, right? We're going to approach this forbidden number, right? We're going to approach this forbidden number. Oh, give me the green, okay? I'm going to approach the green number. What happens? How do you express that? We approach pi from smaller than pi, right? And what happens to the output? The output is going to be as small as possible. Input output. You see, has the nature of input output changed since we talk about the first function, constant function? Absolutely not. It's a very consistent theme of function. The input is horizontal, measured from the same place. The output is vertical, measured from the same place, right? So how do we express what I just described? Are you guys ready for this? Right? Now, right here, okay? There will be other situations, but these situations I'm giving you will be atypical. So if A approaches the 0 angle from larger than 0, okay, cotangent of that angle approaches positive infinity. If A approaches pi from smaller than pi, cotangent A approaches negative infinity. There are a lot more similar situations because we just described one piece of it. We just describe one piece of it, right? We only have described, let me put the vertical asymptote in place, right? Okay, so I'm going to put the vertical asymptote in place, and these are broken lines, and make it thin and make it red. Right, so this is one vertical asymptote, right? X equals 0. And let me put another vertical asymptote here. Right? Another vertical asymptote would be here. Right? So this is just describing in between 0 and pi. And you have a lot of similar expressions. You have a lot of similar expressions in other pieces. And you guys need to know. You guys need to know. Which is similar to this. Okay, I'm not going to do it for you in this class. All right. So that's about cotangent. This is the other two forms. I want you guys to work it out by yourself. And I think some of you probably did, some of you didn't, or whatever you have done. So I have given it to you here. And these are the perks for your calculus classes. These are the perks for your calculus classes. Now, last but not least, two functions, which is secant and cosecant. Secant, cosecant. I urge you guys to do, and I'm giving you a guideline. Okay, I'm giving you a guideline. So I did this with my other class yesterday. So I'm just going to put the outline out there. And you just write it down. Okay, you just write it down. And we're not doing this in class. However, you will see there's a question. There's a question on the quiz that's related to it. Okay, so guide for your study. Guide for your study on, secant and cosecant. Guide for your study on secant and cosecant. Okay, you're gonna work these out. Work these out. Okay, for the secant, cosecant. They are also used in your calculus classes. Okay. Okay, for example, we know that secant is a reciprocal of cosine, right? So from that you can determine domain, but range is a different ball game. Range is a different ball game, right? So you have to do some algebraic analysis, and there are also those algebraic. There's a calculus, perks, and there's also those intercepts discussions. There are also intercept discussions. But because we have seen that cosine as 0, cosine, function as a denominator, sine function as a denominator, so we already have those analysis done for you. You just have to put them there for this specific function. Okay, these two specific functions. So please write it down, and I'm going to leave this for you, and I trust you guys can do it. And if you have any questions, let me know. Okay. So I don't want to deprive you, the opportunity to explore yourself. Okay. If I am to do this, if there's a necessity for me to do this, I would just probably do it in the office hours and then send it to you. And you guys have questions, you come to me during my office hours. Okay. And I will do the recording and make it available for you. And next, we're going to catch. Did you guys write it down? Okay, you're going to fill all of these gaps. Okay, it just make it more complete because these two functions, I didn't put them on the on basic 1 table. So what do we do next? You probably have taken the picture, right? So I'm going to just move forward. The next thing we're going to talk about is to try to fill that gap of where is this come from? Some of you who have not taken trigonometry, okay, I wish to give you some time to just to capture that, okay? So once again, ARD, starting from ARD, right? When we know what's A, right? Do we know what's A? About angle measurement, right? You measure counterclockwise, clockwise, positive angle, negative angle. You measure all your angles from the same place. So we know A. And we know R, right? We know R. Reference angle. What's reference angle? The positive acute angle between the terminal and the x-axis. And then it comes to D, right? A, R, D. What does D say? In D, we chose a point. We choose a point on the terminal side of the angle, right? We choose a point on the terminal side of the angle arbitrarily. And we know that with that arbitrary choice, we are going to be, we can have as many points as possible. Of course, that point cannot be origin, right? But because we choose any point, it's not going to make any difference to the ratios of trigonometry or trig functions, the 6 functions. Therefore, we decide we're going to choose those points to be on the unit circle, right? So all of these are so for example, this is a point, right? This is a point. These are the points. These are the candidates of those points. Okay. If they happen to be here, these are special angles. These are special angles. And we know something very special about them. How about we choose the points off the unit circle? Off the unit circle. If we choose the points off the unit circle, that's your quiz number 10. You still need to know how to do it. Okay, just remember in your calculus classes, sometimes that point is not on the unit circle. And you still need to do it. Did you guys still recall quiz number 10? Right? The point is not on the unit circle. Okay, it's on a circle actually with radius equals to 5. And then what you do? Well, you do the same thing. You do the ratio. You guys have done that, right? You guys have done that. It was a piece of cake, right? Now, with that said and done, how did all these points come to existence? Right? So that's what we're going to talk about. So now, suppose I choose a point. Suppose I choose a point, okay? Suppose I don't know all of these points. Suppose I don't know all of these points. So what I'm going to do is that I'm going to put this away. Okay, I'm going to put this away. And I'm going to go through the rhythm of ARD. I'm going through the rhythm of ARD. Okay. Hold on, that's gonna be 1.5. This is pretty ugly. I don't like to have these messy points. Guess what? I'm going to stop that recording.